Okay, so for this one, we need to know what the relationship is between mass and volume to calculate density. Okay, so density is basically a measure of the ratio between mass and volume. So density always stays the same for any pure substance. It's what's called an extensive property. So density is equal to mass divided by volume. Now, there are a few different standard units for density because it depends on what you measure the mass in and what you measure the volume in, right? So ones you commonly come across in chemistry would be things like grams per milliliter or grams per centimeter cube, but you could also come across, like, I don't know, kilograms per liter. It really is just going to depend, but what you have to make sure is that your units are consistent. So for this particular question, we've been given densities in grams per centimeter cubed. Just as an FYI, there is a very useful equivalency to just know, which is the relationship between milliliters and centimeters cubed. 1 milliliter is exactly 1 centimeter cubed. So if you're ever given densities in grams per centimeter cubed and you need to convert to grams per milliliter, you can take this milliliters equals 1 centimeter cubed and use it to create a unit conversion factor, right? So don't just say, oh, it's the same, right? You should technically convert the units by making sure that either milliliters or centimeters cubed cancels out, depending on which way you're going. Okay. I don't know why that started doing that, but you can stop. So we have an unknown that we have to calculate the density of. We've been given the volume in liters and we've been given the mass in grams. So I could just straight away go and calculate the density. I could do mass divided by volume, grams divided by liters, and I would get a density, and it's going to be in grams per liter. But I do have to convert those units, okay? Because I am trying to identify the liquid, and the densities for the liquids that I'm given, the standards, are given in grams per centimeters cubed. So I am going to have to convert grams per liter into grams per centimeters cubed. Okay, 972 grams divided by the volume, which is 1.040 liters. Now, this might be a good time to talk about the weakest link rule for sig figs, okay? Whenever you are doing a calculation based on measured values, which I'm assuming this mass and this volume is, then you need to be aware of the number of sig figs. The weakest link rules means if I'm doing this calculation, I should only give my answer to the number of sig figs of my smallest number of sig figs in my measured values. So the mass is given to 3 sig figs and my volume is given to 4 sig figs. So really I should only give the answer to 3 sig figs. Okay, so 972 divided by 1.040 gives me 934.615. But you know what? I'm going to write that all down and just go over rounding real quick. Blah, 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 blah. So this is too many, okay? So I need to give it to 3 sig figs, which would be 934. Now, to decide whether I need to round or not, I've got to look at the next digit past the last significant one. The rule is if it's 5 or above, we round up. And if it's under 5, we just leave it. Okay, so if that had been a 4 instead of a 6, I'd just leave that as 934. However, a 6 is 5 and above, so I should actually round this up to 935, and my units will be grams per litre. Okay, so I'm going to write that as grams over litre because I'm going to show you how we can then sort our units out. So I want to get rid of litres and I want to get it into centimetres cubed. Okay, so first things first, before I worry about anything, I want litres on the top and milliliters on the bottom. Can I write a conversion factor, an equivalency between litres and milliliters? Yes, I can, because that is a SI unit prefix, right? So milli is 10 to the minus 3. So 1 milliliter is equal to 10 to the power of minus 3 litres. So I can pop that in, right? 1 milliliter is 10 to the power of minus 3 litres, and I did not leave enough space. What's wrong with me? So that's going to look awful, but there you go. I'm just going to slide it in there. Okay, so that should be in there. It's too big. 10 to the power of minus 3 litres. Okay, so now if I look at how my units cancel, okay, I've cancelled my litres and I have grams per milliliter as my unit. I want grams per centimetres cubed. I've learned my lesson. I'm going to leave more space now. So I want to have milliliters cancelling out, so they've got to go on the top. And then I want centimetres cubed to be on the bottom, and I'll still be left with those. Okay, and I know from the equivalency I just wrote earlier, 1 milliliter is exactly equal to 1 centimeter cubed. I know you're like, well, it's the same. Why have you written it down? Because I have to show that my milliliters cancel. So now my units are going to be grams per centimeter cubed, which will allow me to compare with these guys right here. Did I even do the math yet? I did not. Okay. Okay. So 935 times 10 to the power of minus 3 is 0.935, and the units of that will be grams per centimeter cubed, okay? Or if you like, you can actually write grams centimeters to the power of minus 3. So instead of writing over centimeters cubed, you can also use that negative exponent. You'll find that's used quite a lot in textbooks and like anything that's word processed, like the whole of the internet, because that's often easier to typeset than putting a line and a fraction in there, right? So do any of these guys match? Well, ding, 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 we have a winner. I would say methyl acetate is a good match, okay? So in terms of answering the question, then calculate the density of the liquid. Well, I got, go away news, 0.9395 grams per centimeter cubed. Is it possible to identify the liquid? Yeah, I did. I identified the liquid because I'm amazing at chemistry. If it's possible to identify the liquid, do so. I'm going to say it's methyl acetate based on my density calculation. Okay, so I'm going to just have a look at another and see if they're all the same type of question. Sometimes you get different ones. Sometimes you don't. I think these all may be much of a muchness. Yeah, they are. It just depends on if it's asking you for densities in grams per milliliter or grams per centimeter cubed. So I think you quite confidently can do that now. So go be awesome at that.